Hello, and welcome all my fantastic YouTube subscribers and all the YouTube watchers. My name's Todd, Ellensburg Amplifier here, with a Taramps MD12K on the bench. And I know I have a few, if not several, videos out on the MD12K. But, you know, there are some situations that we run across that I'm a channel that likes to put out information to help others to keep from pulling their hair out, growing gray hair, prematurely aging, whatever it may be. But sometimes an amplifier repair will prematurely age you. Because of the complexity of the situation, sorry, that was my meter. You know, especially to people that are new to repairing amplifiers, and I'm not talking just Korean or Brazilian. I mean, I'm talking any amplifier. Amplifiers are not an easy thing to learn, especially if you have no knowledge in electronics. So, setting aside knowledge of electronics and how things work, we can come down to a couple conclusions of, well, an amp comes in and doesn't work. Well, we're going to find the reason why it doesn't work. For this particular MD12K, upon initial diagnosis, I did not have a signal from the preamp. 9 times out of 10, it's from shorted output terminals, pops the DC offset circuit, shorts out the 319. The 319 shorts out, goes through and destroys IC6, IC2. It goes on. But the preamp, I got that repaired. Just as notes for people that are watching this, on IC6 on pin 1, you should have an output signal on that. I always check pin 1. Is it pin 1? I think it's pin 1 of IC10 and pin 1 of IC6. Pin 1 of IC10 feeds into IC6. Pin 1 of IC6 comes out and goes to, what is that, IC5, I think it is. Regardless, you should have a sine wave on pin 1 of IC6. If you don't have a sine wave on pin 1 of IC6, you have a problem. And just to let you know, I don't have the scope on the screen, but pin 1 of IC6, let me go on pin 1 here, turn on my 12 volts. Pin 1 of IC6, just to let you guys know, if you go ahead and give yourself an input signal, once I have everything properly set up, geez, Todd. Okay, funny. So you will find that pin 1 of IC6 and pin 1 of IC10, and my ground looks a little dirty, will have a sine wave on it without your remote. So what you do is you hook up your 12 volts, hook up your signal, and then you can test, turn your 12 volts on. Then you can test pin 1 of IC6 to make sure you have a sine wave, which I do on the scope right here, without even having the remote turned on, without even firing up the rails, I should say. And then if you come down here to pin 7 of the 319, you're going to find you have a square wave on pin 7, and then you go up to pin 12 of the 319, you're going to have a square wave on pin 12, which, whew, that's a lot of words. I'm trying to get this done as quick as possible for you guys, which leads back to pin 1 of the SI drive ICs. We got a drive IC here and a drive IC here. So pin 1 will give you a nice good square wave on pin 1 there, and then also a nice good square wave on pin 1 of the other SI 8244 Class D IC. So that's how I know that I have a functioning preamp. I don't even have to fire the amp up. I took care of that problem, because that was the original problem that I diagnosed this with, was it had no preamp. And it didn't have any open DC offset resistors. So that told me that it probably had a RCA failure, which is not uncommon to have shorts across your RCA, shorts out the input IC of this, and everything goes south from there. So I just wanted to show how you guys can check your preamp without even firing up the rails. Rails, there's only one rail, positive rail. So then I got that all done, and I was firing this thing up, and gosh darn it, this thing just goes into protect and overcurrent. I checked my resistance. This is where things got a little, this is what I call a ghosting issue. Is I checked my resistance. Oh, power's on. Can't check it with the power on. Guys, everything I do here, just everything I do besides checking that preamp, do with the power off. Especially if you're new to amplifiers and you're not really familiar with the potentials between the positive rail and ground. It's the potential that'll get you in trouble. Gotta let things discharge here a little bit. What happens is the capacitors get charged here, and there we go, your gate circuits, your output to ground, you'll see will have 0 ohms. It'll be open because of the capacitance. So I was doing my checks, my normal diagnosing checks for these Brazilian boards. So what I do is I check from ground to speaker terminal of, and I've got 53K and 80K? Yeah, 87K. So I know I'm, 50K-ish, 80K-ish between ground to the speaker terminal. Let me show you guys what I'm doing. I'm just verifying the resistance between the two output terminals to ground, and then I check here to here. It's like 50K, 50-ish K, 66K. So, oh, that's right, I was 50K here. So 50K, 80K, 66K. And that, I just know from doing these so many times that I already know that my DC offset circuit is fine. You'll have a resistance value here that's way off or really low if there's a problem with your DC offset circuit. So I was like, oh, okay, it's good to fire up. I was like, oh, perfect. I was checking my continuity between the terminal and the inductor. I'm like, yep, we're good. Yep, we're good. And I'm like, okay, well, why is this thing going into protection and overcurrent? Just for the heck of it, right? So I was like, oh, okay. Well, I had my positive voltage here. I can remember what the voltage was. It's 100 and some odd volts. And coming off of the source over here, I was like, oh, wait a minute, 7 volts. I'm like, oh, so I come over here and check with the scope my output terminal. So remember, on full bridge amplifiers, your sine wave rides halfway from 0 reference, 0 volts ground, to positive rail. You're going to see just a straight line on your scope. The line, your trace, going up to middle between halfway of positive rail and ground. But I was only getting like 8 volts. I'm like, oh, I have no voltage, more or less. So I'm coming over here and I'm checking, and I'm on the old dreaded beep mode here, and yep, inductor, come through. Yep, inductor's going through, and then yep, inductor's going through. And I was like, oh, what's going on here? So let me see if I can get these probes right without. All right, hold on, guys. I'm multitasking here. Just trying to show you guys what I'm finding. So, what's this? Beep. And I checked these before I even sent off the quote. They were rock solid, which is rare for silicone, to feel rock solid. But these felt rock solid. Like I didn't question the inductors at all. This was rock solid. So when I was wiggling it, twisting it, and I was picking up this insulation with my needle nose pliers, checking the legs of the inductors, because what's one of the failures of these boards? Inductors. Huge problem. And then I'm like, oh, I have no continuity now. What happened? They're like, well, there we go. We have the singing inductor issue. So, there you go. I will bet money, since I've already double checked everything. I've even checked the gate drives. Gate drives are fine. I'm like, that's odd. I have gate drive, I have positive rail, but I have no output. Right there. So I start lifting up the insulation over here, and lo and behold, guess what happens? The whole inductor pulled right on out of the board. So guys, don't let a ghost fool you. Try to keep in mind the common issues, common failures of amplifiers, and you'll save a lot of time. And never underestimate that just because you see silicone everywhere in an amp, that something hasn't failed from vibration damage, because that's what this is. This is a vibration failure. So yeah, don't underestimate the inductor. The thing is I gotta try to fix this now. So an inductor repair, thank goodness I quoted this high, because it was a preamp failure, and preamps can become a pain. But I quoted it a little high, which is good, because now I got to repair an inductor. So I just wanted to share that with you guys. Check your inductors. Just because they feel tight, yeah, that means nothing. So double check, pull up the insulation on check your joints on your inductors. It's hard to tell these back ones because they're right up against those capacitors. But when I was pushing my probe through here to test the continuity between the transistor and the, I'm going to call it the input of the inductor, I heard something a little crunchy, and there was no continuity between the transistor and the inductor, and then I knew that that was the problem. So just want to share with you guys. Hope you find that problem. Sometimes the problem's right in front of your face. So thank you guys for watching. If you got any questions, comments, concerns, or whatever it may be, leave them down below, and I will get to you guys as quick as possible, and I'll answer any questions the best that I can. As I do, I love to help others. And please, keep your fingers out of the rails. The voltage here is spicy. So thanks for watching. We'll catch you guys on the next one.